Hello, my name's Frank, and today we're going to work on simplifying square roots. This is sort of a review assignment on square roots, so I have a few of each type up here and just going to go over them. So let's talk about these problems. First off, this is the principal square root symbol, and the principal square root of a number is always greater than or equal to 0. So the principal square root of 36 we know is 6. The reason is 6 times 6 is 36. And remember, it's the principal square root, so it's always the positive one. Okay, we go to our next example, and there's two ways we could do this. We could divide 16 into 400, that's fine. Or we could take the square root of 400 over 16, the square root of 16. So it's up to you, your preference. Do you want to divide first up here and take the square root of the result? Or do you want to take the square root of the numerator divided by the square root of the denominator? Okay, we'll choose this one. The square root of 4 is 2. And the square root of 2 zeros is 1 0. The square root of 16 is 4, and 20 divided by 4 is 5. So that's a quick way to do it, or you could divide initially. All right, our next one is 9 square roots of 9. So the square root of 9 is just the number 3, the principal square root. So all that is 9 times 3, which is 27. Now we go to problems that have irrational results, like the square root of 8. Now, there's no perfect square root of 8. The square root of 4 is 2, and the square root of 9 is 3, but what's the square root of 4? 8. Okay. In simplifying this, we're looking at a perfect square which would divide into 8. 4. 4 goes into 8 2 times. 4 times 2 is 8. Now, if you take the square root of 4, you get the number 2. So this comes down as 2 square roots of 2. A lot of times when I do these square roots, I'll list the perfect squares for the students. I'll say 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 6, and we'll go down the page quite a way. I say, let's erase the 1. Do any of these numbers divide into 8? And we're looking for a number that divides into 8. And we notice 4 does. Okay, so we're looking for a number that will divide into it. Now, sometimes there may be 2 numbers that would divide into it. Example is the square root of 108. If I were to say to the students, what's a perfect square which goes into 108? Well, immediately someone will say 4, and I'll say, good job. Another student will eventually say, wait a minute. How about the number 9? I say, good job, that'll divide into there. And then finally, someone might just take a little more time and say 36. So which one is, they will all work, but this one will get you your answer faster. So I guess if there's a moral of the story, is if there's multiple squares to divide into the 108, to get the answer the quickest, choose the larger square. Okay, so we'll practice that on one in just a minute. Let's look at the square root of 18. Now, the square root of 18 has a perfect square contained in it as 9. 9 and 2. The square root of 9 is 3. Now, you can multiply the 6 times the 3 and get 18. And the answer is 18 square roots of 2. Okay. Our next example is a fraction 3/4 times the square root of 32. So let's look at the two alternatives. If I said to a student, give me a number that divides into 32, which is a perfect square, someone would say 4. I'd say, okay, 4. And they would write 4, and I'd say, what's left over? They'd say 8. Very good. Well, what's the square root of 4? They would say 2. I'd say, very good. So what do you have here? You have 6 over 4, 3 times 2, or you could divide, 2 goes into 2 once, 2 goes into 4 twice. So you would have 3/2 square roots of 8. Well, wait a minute, 8's not done. 8 can be broken into the square root of 4 times the square root of 2. The square root of 4 is 2. And then these 2's will divide out, and you're left with 3 radical 2. So you look at the work and say, wow, it's a lot of work there. Let's back up a minute. Instead of using 4 and 8, why don't we go to the side of it and try it this way? Stay with it a little longer and you just say 16 divides into that. 16. 16 goes into 32 2 times. So notice we're choosing a larger square between the 4 and the 16. We're taking the 16 this time. Well, what's the principal square root of 16? That's 4. And then these 4's cancel. And we're left with this. So notice the difference in the work. I think you'll agree if you take the bigger perfect square, you'll get the answer faster. Okay? So there's your answer. Either way you do it. Okay, some multiplication. We're going to distribute this one. 5 times -5 is -25. And what follows is the root of 2. 5 times 4 is 20. And I'm going to show you this today. Then next lesson we'll talk about inverse operations. This would be the square root of 5 under there. Now, you say to yourself, am I done? Well, let's look at these terms. This is a square root of 2, and this is a square root of 5. They're different terms, so they can't be combined, so you are finished. That's this one. Our last one on this side is -7 roots of 2 times 6 roots of 2. So we multiply the numbers. -42. And for today, we're just going to show you the root of 2 times the root of 2. You multiply the two numbers under the radical. They're called the radicands. 2 times 2 is 4. The square root of 4 is 2. And when you multiply this, you get 84. Our next example is 9 square roots of 2 quantity squared. So to get the feel for this, when you square something, you just multiply it by itself. Now the 9 times the 9 is the 81. The square root of 2 times the square root of 2, for today, we'll write it as the square root of 4. But the square root of 4 is 2. So we have 81 times 2, and we have 162 as our answer. Okay? All right, next example, we have a distribution, numerous radicals, so here we go. We have our 5 times our 3, which is 15, and again for today, we'll just go to square root of 3 times the square root of 3 is the square root of 9. Well, now you may be seeing a pattern. When you multiply the square root of a number by itself, you just get that number and the result. This will be 3 in just a minute. Now, when we multiply this, we'll get -10, and the root of 3 times the root of 2 is the root of 6. Now, we ask ourselves, can we continue? Yes. As previously stated, this will be 3. So it's 15 times 3. Now, is there a perfect square other than 1 that will divide into 6? And you will say no. 4 doesn't, and then 9's over top of it. So this is 10 roots of 6. And our answer to this would be 45 minus 10 square roots of 6. Okay? All right, our next one is multiplying a binomial times a binomial containing radicals. So we either double distribute, or some people call it FOIL. 2 times 1 is your 2. 2 times your negative 2 roots of 3, which is negative 4 radical 3. Your 3 radical 3 times 1 is your 3 radical 3. And then your last 2 terms, careful here, that would be negative 6. Root of 3 times the root of 3 would be the root of 9. Okay. Now, we have 2, and these are the same square roots. So they're like terms. So you have negative 4 of them plus 3 of them, which is negative 1 of them. You don't need to write the 1 unless you choose to. And this is 3. Okay. Now, we do our arithmetic right here, and 6 times 3 would be negative 18. And then we combine our constant terms of 2 and negative 18, and you get negative 16 minus the root of 3. And if you choose, you can put this term first and this second. Okay? And then our last one is another one foiling, but we have one additional twist to this. So we FOIL or double distribute, that would be the square root of 18. This would be the square root of 12. This would be 3 radical 3. And this will be 3 radical 2. Now, we can simplify the root of 18 by taking out the 9. 9's a perfect square. And that 9 times 2 is your 18. You can simplify the root of 12 by taking out the 4. 4 times 3 is 12. The square root of 3 is intact. It stays the way it's written. Likewise, the square root of 2. Okay, the square root of 9 is your 3. Your square root of your 4 is your 2. And then you rewrite your latter terms. And then you say, all right, can I put them together? Well, let's look. You got 3 radical 2 and 3 radical 2. They're like terms, radical 2. And you add them and you get 6 radical 2. These are likewise like terms, 2 radical 3 and 5 radical 3. They're both radical 3's, and 2 of them, 3 of them is 5 of them. So our answer to that is 6 roots of 2 plus 5 radical 3. So anyway, this was a review, quick review of some basic radical properties. I hope you found them useful, and I'll see you next time.